Hello, this is Mr. Huff, and I wanted to go through the physics study guide for Unit 9, where we talk about waves and sound and light. Number 1, know these definitions. That's pretty straightforward. Make sure you have written down and studied the differences between compression and diffraction, frequency, period, rarefaction, reflection, refraction, and standing waves. Be sure to note any differences. Number 2, describe what happens to a transverse wave as each of these is increased. This is where we played with the wave on a string simulation, and if you need to go back and look at that some more, that would be recommended. But if you change the amplitude, the only thing you change is the energy. Nothing else changes. If you increase the frequency, the period decreases, and so does the wavelength. The velocity does not change. Go back and look at the formula. The wave's velocity is the product of the wavelength times the frequency. Number 3, know how to identify a harmonic and resonance values. For identifying the harmonic, you need to simply count the number of antinodes. To find the resonance values, it's multiples of the fundamental, and the fundamental is the frequency for one antinode. So you need to make sure you know how to do that. We've given you several worksheets that include calculating harmonics, so you should make sure you're familiar with that. Where can you touch a string on a standing wave without disturbing the wave? The answer is on the node. The node isn't moving anyway, so you can touch it. If you touch an antinode, you're definitely going to interrupt the wave. What factors change the period of a pendulum? In your investigation, you found that mass makes no difference. But if you change the length, or if you change the gravity, the behavior of the pendulum will change. Less so is anharmonics. If you exceed about 15 degrees displacement from equilibrium, you will begin seeing anharmonic behavior. Number 6, recognize the effects of diffraction, absorption, reflection, refraction, and beats. I would suggest Googling these and looking at the various diagrams and images that appear. We've talked about all of these at this point except beats, and we will go over that before the exam. Number 7, draw and label diagrams for transverse, longitudinal waves, and surface waves. Again, find some pictures, draw them. Draw and label diagrams of constructive and destructive interference. You need to recognize which one amplifies the wave and which one reduces the wave. List the characteristics of sound waves. Compare the speed of sound in gases, liquids, and solids. Remember that sound moves by sending energy through a medium. The closer the particles are together, the easier it is for the sound to travel through it. So the speed of sound is slow in a gas. It speeds up in a liquid and is as fast as it can be in a solid. Number 10, list the characteristics of electromagnetic waves. We will have a reference page for you, so you just need to know how to interpret that. You need to recognize, as you look at the electromagnetic spectrum, as you go from left to right or right to left, how the frequency is changing, how the energy changes, and how the wavelength changes. Draw and label the diagram of a ray striking a mirror. Include normal incident and reflected components. There are some diagrams in the worksheets that we've given you showing a ray of light striking a mirror. It shows an arrow moving toward the mirror, bounces off at exactly the same angle, measured from normal or from the surface of the mirror. Number 13, list the characteristics and colors of additive color theory. List the characteristics and colors of subtractive color theory. You need to make sure you understand which one is related to white and the 3 colors, white light, and the 3 colors that go with that. And you also need to recognize which ones are related to paint and pigment and which colors are related to that. You need to be prepared to do some calculations using the wave velocity formula, the straightforward velocity formula where we look at distance divided by time, and the formula for period or frequency, recognizing that they are inverse proportions. And that's all you need to be ready for on this.